in this video, we will do an example where we count the number of PIN numbers. So the example says that a new PIN number has 3 digits, and each of the digits in the PIN number is among 0, 1, 2, all of these integers up until n. And part A of this question asks, how many different PIN numbers are possible? Part B asks, how many PIN numbers are there if no digit is repeated? So I want to give you all the opportunity to try this question on your own first. Pause the video for 3 minutes to try this question. 4, 3, 2, 1, pause the video. Pause it for 3 minutes to try both A and part B. Alright, so hopefully you did that. Hopefully you paused it for 3 minutes to try this question. So let's talk about it together. So part A, I want to find how many PIN numbers are possible. So usually in the real world, PIN numbers have 4 digits, but for the sake of this example, I'm making them have 3 digits. Okay, so I need to, so there's 3 stages to this. I'm going to pick something for the first digit, and then something for the second digit, and something for the third digit. So we are going to use the multiplication principle here, because the number of outcomes for the second digit doesn't depend on doesn't depend on the outcome for the first, and the number of choices for the last digit doesn't depend on the outcomes of the first 2 either. So in A, there's no restrictions here on what any of these digits can be. So that means that there are 10 choices for each digit. They can be any of the integers from 0 through 9. So I'll have 10 times 10 times 10. And multiplying these out, we get 1,000. 1,000 such PIN numbers. So that one wasn't too bad. Pretty straightforward. At least pretty quick to get the answer. And then let's do part B, which asks how many... whoops, I realize this is misspelled. This should say how, with a W. How many PIN numbers are there if no digit is repeated? Okay, so again, I'm interested in counting the PIN numbers. And there's still 3 stages to this: picking the first digit, picking the second digit, and picking the third digit. So I need to be careful here because I don't want to repeat digits. So I'm going to think about this digit by digit. For the first digit, there's 10 choices. I'm going to first pick what goes there. So I'll put a 10 there. And then after I pick what goes in that first digit spot, now there are 9 choices left for the second digit, because it could be anything except the first digit. So for example, if my first digit happened to be a 6, well, my second digit just can't be a 6, but that still leaves me with 9 choices. Okay, so a 9 goes here. And then when I go to the third digit now, once I've picked what goes in the first spot, once I've picked what goes in the second spot, that still leaves me with 8 choices left because I've picked different things in those 2 spots. So there are 8 choices left because it's anything except the first 2 digits. So I got an 8 here. And if we multiply these values out, 10 times 9 times 8, we get 720. So we have finished our last goal for this section, which is talking about how to count the number of outcomes in a multi-stage experiment using the multiplication principle.